Hello guys, now I will try to solve some questions about Fourier series and it's a kind of one type of Fourier transform if you remember from our class discussions. We were like writing our function g of t or f of t is equal to our DC component plus our coefficients of cosine 2 pi n over t plus we have m from 0, m from 1 to infinity. It is bm sine 2 pi m over t, okay? As I discussed again, 2 pi over t is my fundamental frequency. And if I multiply it by n, that means this is the harmonic, okay, nth harmonic of the fundamental frequency. That means if my fundamental frequency is, let's say, 10 seconds, if my fundamental period is 10 seconds, then my fundamental period is 2 pi over 10. And if I have second harmonic, that means 10 2 times omega 0, which is 2 pi over 5. That means the period of the 2-second or second harmonic will be 5 seconds, okay? So these are the harmonics. These are the harmonics. And this is my DC coefficient. And these are the coefficients for cosine, coefficients of sine, okay? We were doing some examples. If you remember, we had this periodic signal whose period is t, and it was like changing between 1 and 0, 1 for certain amount of time, and then 0 for another amount of time for one period. Okay, we were trying to solve the question, and we were trying to find out A0, ANs, and BNs. If you remember, we found A0 to be the area under the curve. This is, let's say, T over 2, and this is 1. The area under the curve is like 1 times T over 2, 1 times T over 2, and we will divide it by T to obtain the average signal, okay? DC component is the average signal. And then we will get 1 over 2 as our average. So when you look at this, this one, the one on the right panel, you can see that we have a sinusoid, like this is a sine wave, and this sine wave is very similar to the one that we have here. And there is one 0.5 DC level here. This is 0.5, and this is my DC level. And I'm trying to find out by adding these signs in order to obtain this square pulse or like a pulse in a certain time period like that, okay? So I will try to explain to you how I find B1 and then how do we find ANs and BNs. And here are some coefficients. Here are some formulations that I explained to you regarding A0, BN, and AN calculations. And you see this is the average of my signal from 0 to T. And my signal was something like this. I'm only focusing on one period, okay? Only one period. Work on only one period. Don't try to do everything on all the signal. Just focus on one period in order to find out A0, AM, and BN, okay? So as I said in the class, we are trying to find out the similarity between our signal and the cosine at different frequencies. At different frequencies mean This is my fundamental frequency, and this is the nth harmonic. I'm changing the frequency. I'm changing the frequency of my harmonic, and I'm multiplying them, finding the similarity between my signal and my cosine at that frequency, or I'm trying to find out the similarity between my signal and the sine wave at different harmonics. How do I determine the harmonic? I determine this should be N, this should be M. I'm trying to find out the harmonic. I'm changing N and M, and then I'm trying to find out the coefficient. What was the coefficient? It shows the similarity between my signal and that cosine in that peculiar or particular frequency, okay? So I'm going to take my signal, put it here, and multiply with a cosine, and then take the integration along the period, and then multiply by 2 over t for obtaining ANs and BNs, okay, or BMs. Let's continue. I told you we can find A0 like that as being 1 over 2. And then let's continue with AM and BN. For example, let us look at AM equals 2 over t from 0 to t, and my f of t is 1 from 0 to t over 2 times cosine 2 pi m over t dt. Okay, this is how I find AM. For this signal, I'm only focusing on this part, and like half of my period is 1 and the other half is 0. So that's why I change my boundaries accordingly. So if I do this 2 over t from 0 to t over 2 cosine 2 pi m over t dt. What is the cosine's integral? We have to take this one and flip it, right? 2 over t times t over 2 pi m from 0 to t over 2, and I'm gonna take it out. It should be sine 2 pi m t from 0 to t over 2. Okay, so this is my AM, because the derivative of sine is cosine. So and integral of cosine is sine. Okay, so that's how we go, and then we will say t will go away, these 2's will go away, and I will have 1 over pi m times sine of 2 pi m over t. I'm going to put, instead of t over 2 minus sine 0. Okay, so I'm applying an integration, which is going to be equal to, this is 0, this is sine, these t's will go away, and I'm going to get pi m divided by pi m. Okay, so these are AMs. If you put, instead of m, 1, you're going to get sine pi. What is sine pi? If you draw this, this is cosine, this is sine, and it's going to be like pi. What is sine pi? It is 0. What is sine 2 pi? It is 0. Sine 2 pi is also 0. For any m, this is going to be equal to 0. So AMs are equal to 0 for all m is equal to 1, 2, 3, and so on. Okay, so this is how we approach to this problem. that means this signal is not similar to a cosine signal at all, okay? Because when you look at this, it is like a sine signal like this. Okay, it looks like a sine, so there is no cosine component in this part. So we will look at the Bn. So I'm going to do a similar thing, 2 over t from 0 to t over 2 times 1 times sine 2 pi n t over 2 t dt, right? I'm doing this thing here. I'm putting 2 over t from 0 to t over 2 because I only have signal from 0 to t over 2, and I'm going to have the sine part here. What did I do? 2 over t times t over 2 pi n times minus cosine 2 pi n t over t. So the sine's integral is minus cosine, okay? The derivative of cosine is minus sine. So we do this, and then the boundaries are from 0 to t over 2. So I'm going to write Bn like that. So 2's will go away, t's will go away. Again, I will have pi over n here, and I will have this one. So I'm going to write Bn is equal to 1 over pi n times minus cosine 2 pi n t over 2 divided by t. Okay? Minus cosine minus cosine 0. Why 0? Because this 0 goes here and it becomes cosine 0. Okay? So it will be like minus cosine 2 pi n over t. T's will go away, 2's will go away. And then I will have, what is cosine 0? It is 1. Minus minus is plus 1. And this is minus cosine pi n. And then I'm going to write Bn is equal to 1 minus cosine pi n divided by pi n. Okay, this is Bn's. And if you put Bn's like that, if, for example, if n is 1, what is the result? Cosine pi. What is cosine pi? It is minus 1. So it will be minus 1. 1 minus minus 1, 2. 2 over pi, right? B1 will be 2 over pi. If you put 2, cosine 2 pi is 1. So 1 minus 1 is going to be 0. So for the odd ends, I will have 2 over pi n. For the even ones, okay, let me write here for n odd, the Bn's will be equal to 2 over pi n. For n, an even number, Bn will be equal to 0. Okay, so you can check that on your own also. It is very critical that you understand this. This is all about integration and putting the correct things and doing everything one by one. Okay, see you in the next video.